What do RNN internal states mean? Imagine trying to remember the last few words of a sentence while you're talking. Your brain keeps a little memory of what has been said so far. In recurrent neural networks, or RNS, this memory is called the internal state. Think of it as a small container that holds information from previous inputs. This internal state is like a summary of everything the network has processed up to that point. It helps the RNN understand the context of what it's working on. Every time the RNN receives a new piece of data, like a word or a sound, it updates this internal state. It combines the new input with what it already remembers. This process uses mathematical operations called weight matrices and activation functions. These are just fancy terms for how the network decides what to keep and what to forget. The previous internal state carries details from all earlier inputs, so the current state is a snapshot of the entire history of the sequence so far. This ability to remember past information makes RNS great for working with sequences. For example, in language models like ChatGPT, the internal state helps the model understand the flow of a conversation. It remembers earlier words and sentences to make sense of what is happening now. In speech recognition or time series analysis, the internal state helps the network recognize patterns over time. The internal state is essential because it allows RNS to capture relationships that happen over long periods. This is especially useful for tasks like translating languages or predicting stock prices. However, simple RNS sometimes struggle with very long sequences because they have trouble keeping all the information. This led to the creation of advanced versions like long short-term memory and gated recurrent units. These models use special mechanisms called gates to better control what information is stored or discarded. In simple terms, the internal state in an RNN is how the network remembers what came before. It acts like a memory that helps the network make smarter decisions based on the past. This concept is at the core of many AI systems that need to understand sequences, like chatbots, translation tools, and speech recognition systems. Without this internal memory, these models wouldn't be able to grasp the context or maintain coherence over time.